In this video I'm going to look at one additional work example. If you don't know what work is, then you should watch the work video first, but if you'd like a little bit of extra help, then this is the video for you. So let's look at a different example. Here is an absolutely massive cannon up in Scotland. Each one of these cannonballs weighs 175 kilograms. Now if we calculate the gravity force on that, multiply it by 10, that gives us 1,750 newtons. If it's gone up a height of 0.9 meters, then that force required to lift it must be the 1,750 newtons multiplied by the distance that it's moved. And because it's moving up, we use the gravity force, which is a vertical force. Both of them are up and down, therefore they are parallel. In this case, it's done 1,575 joules of work. Now let's imagine that that cannonball is placed inside the back of the cannon and fired out of the cannon. We obviously know the gravity force acting down, because we've calculated that already. And there's also going to be a force due to the gunpowder. Now the question is, in our work equation, which one do we use? Do we use the downwards gravity force, or the gunpowder force pushing it out along the barrel? Well, it's obviously going to move along the barrel. It moves in fact a distance of 2.8 meters. So because it's moving in this direction, we use the force that is in that direction. So we use the gunpowder force, not the weight force. So in our equation, we put in 850 newtons multiplied by the 2.8 meters that it moved, gives us 2,380 joules. So, how fast would it be going when it left the end of the barrel? Well, now we go back to what we did with kinetic energy in the last video. We know the amount of work that was done, and the amount of work is equal to the kinetic energy, because it's equal to the change in energy. The cannonball started with no kinetic energy, and ended up with kinetic energy. So that change must be equal to the amount of work. In this case, 2,380 joules. We can now look at our kinetic energy equation. We're trying to find the speed, so cover that up. Substitute in our values. Here we are using the 2,380 joules that we calculated as work. We get a v squared of 27.2, which when we square root, tells us it's going to leave that cannon muzzle at 5.21 meters per second, which is quite low. So I think 850 newtons is way too small for our gunpowder force.